All right, so anyway, the questions are basically, your midterm, guys, is going to look very much like this here, okay? But I think I told you all in the email that the midterm is going to have 25 questions, right? This has 50, okay? But so the midterm is going to have half of this, okay? So the first few problems here are basically multiple choice, and you'll have a couple of multiple choice questions on the test as well. But the first one says, determine if the set is well-defined or not well-defined. Okay, so it's asking us the set of the 5 worst U.S. airports. Okay, so my question, what do you think, well-defined or not? Not well-defined, right? So this is going to be not well-defined. And again, the reason being, the key word here that's telling me that it's going to not be well-defined is the word worst, right? What does worst mean? Well, somebody might say, oh, the McAllen Airport's the worst one, whatever it happens to be, right? Come on in, come on in. All right, let's take a look here. Part number 2. Is the set well-defined? The set of U.S. vice presidents. What do y'all think? Yeah, this is well-defined, right? And I have some of the reviews right here if you need them. So that is well-defined because, again, we can go like to Google. We can say, Google, can you tell me all the U.S. vice presidents? And they'll give us a list, right? Same thing for U.S. cities. This is also going to be well-defined because we can, these are things that we can verify, right? So that's the nice thing about figuring out whether or not a set is well-defined or not. If it's something you can actually verify, then we're good. Okay, so let's see. Number 4 says, determine whether the set is finite or infinite. Okay, so the set of odd numbers that are greater than 17. Okay, so if it's going to be greater than 17 and it's going to be odd, then the first one I'm going to look at is going to be 19, 21, 23, 25. Am I ever going to stop? No. We're going to keep going on forever, right? So that's going to be infinite, right? Okay. Let's see. Number 5. Determine whether the following set is finite or infinite. What do y'all think? Finite or infinite for number 5? Anyone know? It's finite, right? Because how many elements do we have? There's 4 of them, right? So guys, remember what finite means, right? You can actually count them out. Yeah, we can count them out. Alrighty. So now let's go ahead and go on to number 6. It says express the set in roster form. So the set of natural numbers between 17 and 161. So again, if you notice here, this is also a multiple choice type question. So again, like I said, you will have some multiple choice questions. I want to say out of the 25, maybe 8 or 9 of them are multiple choice, and the rest are you're going to have to, kind of work them out. But let's see, natural numbers between 17 and 161. So we're going to look at numbers that are, what's the next number after 17? 18, right? And what's the number right before 161? 160. Okay, so I'm going to look for numbers something that looks like that. So my question is, out of the A, B, C, D, E, F, G that we have, which one does it look like it would be like that one there? A, right? A is going to be the one. Okay, and again, the reason we wouldn't pick this one here, those dots mean we're going right even earlier, so we would include like 17 and stuff like that. Same thing with those there, right? Alrighty. Number 7, it says express the set in roster form. So it's a natural number that's going to be greater than or equal to 3. So again, just a quick reminder, remember natural numbers look like this, right? And they go on forever. And we want them to be bigger than or equal to 3. So my set should look something like this, right? And so if I look and I say, okay, well, which one looks more like that? Which one starts at 3 and keeps going on forever? A, B, C, D, E, F, or G. Wouldn't it be E, right? That's the one that looks kind of like that, right? Good. All righty. Okay, so let's see. Number 8 says, determine whether the pair of sets is equal, equivalent, both, or neither. Okay, so first off, to be equal, remember what something means to be equal. They have to be exactly the same, right? So I look at those, and I notice, okay, they're not exactly the same, right? Okay, then what does it mean to be equivalent? Equivalent means we're going to figure out how many different items are in the first set. So when I look at the first set here, 1, 2, 3, right? So the number of elements in A is 3. And then if I look at the number of elements in B, 1, 2, 3, 4, well, the number of elements in B is 4. In order for them to be equivalent, they would have to have the same number, okay? And they don't, so they're going to be neither. They're not equal because I know chemistry is not there, right, in one of them, but they're not equivalent either. They'd have to have the same number, okay? All right, let's see. Let's try doing the same thing here, and let's figure out, are they equal, equivalent, both, or neither? Okay, so first part, let's figure out how many elements are in A. Is it 3? Because computer science is one of them, right? And then physics and biology, so there's 3. Okay, and then for B, we have physics, history, biology, computer science. So here we have what, 4? Okay, so I know they cannot be equivalent, and it does not look like they're equal because we don't have the history part. So again, this is also going to be a neither, right? Okay, let's see. It says determine whether sets A and B are equal, equivalent, both, or neither. And it says A is a set of letters in the word dawn, and B is a set of the letters in the word win. So again, let's see, the set of letters. So how many letters do we have here? Yeah, so the first one's going to be 4, and this one here is going to be, what, 3? Okay, so I know they're not equal, and they're also not equivalent, right? So actually, before I go on, I want to give you an example of something that would be equivalent but not equal. So if I were just to kind of do this on the side, and I were to say, look, let's take a look at the set A. And suppose I told you the set A was that set right there. And then we said the set B would be these right here, this set, okay? And then we said, you know what, let's do this. For this particular set right here, what's the number of elements in A? We have 4, right? We have 4 different letters. And then if we were to say, okay, how many different numbers do we have in B? 4, right? Then those two right there would actually be equivalent, right? And I ran out of room there. But that would be equivalent, right? So they don't look anything alike, right? One has letters, one has numbers, but the fact that one of them has 4 letters, the other one has 4 numbers, they're going to be equivalent, okay? So that's really what the definition of equivalent means. Alrighty. Let's take a look at number 11. So number 11 says determine whether, let's see, A equals B, A is a subset of B, B is a subset of A is a proper subset of B, or B is a proper subset of A, or none of them apply. Okay, so first off, if we were to look at, are they equal? We could look at them and we can say, no, they're not equal, right? They're totally different sets. So I know they're not equal. Okay, now let's figure out, is A a subset of B? What does it mean for A to be a subset of B? It means that everybody here can also be found in B, right? So spring, yes. Autumn, no. Okay, so we know that it's not a subset. So I already know that that's not true. And if we know it's not a proper subset, then guys, we're automatically going to know it's not a proper subset either. Okay, if it's not a subset, it won't be a proper subset either. So a proper subset, I'm going to show you right now when we do this next part. So look, let's do this piece here. Let's figure out, is B a subset of A? So in order for B to be a subset of A, yeah, this one here is going to be here, and this one here is going to be there. Okay, so we know that B is a subset of A. Very good question. Now, what does it mean for it to be a proper subset? In order for B to be a proper subset, that means that there has to be at least one other piece in here that was not there. So we say, well, is there? Yeah, look, it had winter. Not only did it have winter, it also had which one? So all it means is, in order for it to be a proper subset, that this one here has to be at least a little bit bigger. Okay? So very good. So now I'm glad that you asked that question because I think it's a good one to ask. Let's take a look at number 12. It's the same type of a problem. So guys, on number 12, we're going to figure out same kind of thing. Are they equal? Is one a subset of the other one? Are they proper subsets? Let's figure it out. So if I look at part A, it says x is an element of the natural numbers, and it's smaller than 14. So what I'm actually going to do here is I'm actually going to list them out. So if I'm going to look at natural numbers, I'm going to look at numbers that look like this. Okay. When are we going to stop? But remember, because it has to be what? Smaller than 14, so we're going to stop at what? 13. Very good. Okay. Now let's do the same thing for B. Okay. So B is a natural number. Okay, to make sure that we understand what this kind of notation means, I want you to look at the x. The x is between the 1 and the 13. And because we have those little equal lines there, we are going to include those numbers. So we're going to include all the numbers between 1 and 13. Okay, so now, if we take a look at those two sets, look what the directions tell me to do. It says select all that apply. Let me ask you a question. Would you say they're equal? Yeah, they're equal. So we're going to pick that one. Okay. Now, we want to know, is A a subset of B? If I pick anybody in the set A, would it also be in this set too? Okay, so we're going to pick this one as well. Okay, what happens if we went vice versa? If we were to pick anybody here, could we find it in the first one? Yes, okay. Now, remember what we said about proper subset. In order for it to be a proper subset, one set has to be a little bit bigger. Are either of them a little bit bigger? No, so we would stop right there. Those would be the three that I would select. Good, excellent. All right. So, let's see. Same kind of question. Let's see. Determine whether they're equal, a subset of each other, or proper subsets. So it says, okay, set A is a set of people living in North Carolina, and set B is a set of people living in a state with a border on the Atlantic Ocean. Okay, so number one, let's see. Do you think they're going to be equal? What do you think? So look at this here. This is just looking at the people living in North Carolina. This is looking at the people living in a state that borders the Atlantic. Would they be the same? No. So they're not going to be equal. Okay. Now, is A a subset of B? If you're living in North Carolina, would that be the same thing as saying that you live in a state that's on a border of the Atlantic Ocean, right? So you might say, you know what? I don't know a whole lot about North Carolina. I live in Texas. What do I know about North Carolina? So let's go like this, map of North Carolina, and let's see what we pull up. Okay, so if I do this, here is the Atlantic Ocean, right? So here's North Carolina. Okay, so doesn't it border the Atlantic Ocean, right? It's one of the states that goes all along through here. So if I come back to this piece, so if you're living in North Carolina, then you're also somebody who lives in a state along that border. So we would say that A is a subset of B. So I'm going to pick this one right here. Okay. Now, I know it doesn't work the other way around because there's other states that border the Atlantic Ocean that don't happen to be North Carolina. So I know that B is not going to be a subset of A and B is not going to be a proper subset of A. What we have to figure out is A going to be a proper subset of B? Meaning, if you live in a state, if you live in, North Carolina, we know that if you live in a state, North Carolina, you also border the Atlantic Ocean, but the states that border the Atlantic Ocean has to be a little bit bigger. Would you say that's going to be a little bit bigger? Yeah. So it's going to be those there. All right. Let's see. So let's see. Number 14. Okay, let's figure out, are they equal, so on and so forth. Okay, so we have 1, 2, 3, 4, 5. and we have 2, 3, 4, 5, 9, if I kind of put them like numerically. So I know they're not equal, right? Okay. Is everybody in here also in there? No, because 1 isn't, right? Okay, what about the other way around? Is everybody in here also in there? No, right? Because, let's see, 9 isn't, right? Okay, so I know that they're not subsets, and if they're not subsets, then they're not proper subset either. So what would be my only option here? So, yeah, this would be one of those none of those, right? They're not equal, they're not subsets, and if they're not subsets, then these are automatically going to be scratched out as well. Okay. Good. Let's see. The next one here says determine whether they're equal, same kind of problem. Okay, so A is a type of drink, and B are the specific drinks, water, juice, wine, and tea. So we know that they're not equal, right? Because there's other drinks. And we know that A is not going to be a subset of B because we can pick a drink that is not water, juice, wine, or tea. So again, if I automatically know that A is not a subset of B, then I can automatically scratch that one too. Okay. So now the one we want to figure out is B a subset of A. Is water a type of drink? So is juice, so is wine, so is tea. So we know that B is going to be a subset of A. And then would you all agree that it's also going to be a proper subset? Because there's other drinks that are not wine, juice, wine, or tea, or water, juice, wine, or tea. So those would be the two that I select, right? Let me scroll over. Okay, so here we go. Let's see. So this is, again, a multiple choice question, and it says for the sets U, A, and B, just construct a Venn diagram and place the elements in the proper regions. All right, so let's take a look here. So if y'all remember when I made these videos and we were doing this kind of stuff, like I'm going to do this number, here's my A, here's my B, right? Okay, so the first thing I want to do is I'm going to look at this set here and that set there. Hello. And there's the review sheets right there. So my question is, what would these two sets have in common? What numbers are common to both of them? 4 and 8? Okay, so look, right here in the middle, we're going to put 4 and 8. Let me make that a little bit better. There we go. So 4 and 8. Okay, so look, when we come back to A, once we've taken away 4 and 8, the only thing that's left over is the...
Sorry, can I follow?
Yes. There you go. Is the 3, right? And then when I come to B, once I take out the 4 and the 8, all we're left with is 1, 2, and 6. And then if I come back to, let's see, this one right here. So we've used 1, we've used 2, we've used 3, 4, 6, and what, 8? So where we're going to put 5 and 7? On the outside, right? So 5 and 7, awesome, would go outside. Okay, so now all I'm going to do is to say, okay, out of those choices that we have there, which looks like the one we drew? C? No, not C, right? Because look at C. Yeah, B would be my answer, right? There you go. Yeah. Yeah, C is repeating that 8 a whole bunch of times, isn't it? Yeah. So let me ask you a question. When y'all were doing this, did these problems make sense as like in the videos that I set up for y'all? Did it seem okay? All right, I'm just checking with y'all. All righty, let's see. Number 17, it says for the sets U, A, and B, we're going to do the same kind of thing here. Okay, so instead of me actually I can draw the picture like we did before, but let's see if we can do it just kind of looking at the choices that we have. So remember what we said first. I'm going to look at my set A, I'm going to look at my set B, and I'm going to ask myself, okay, what letters do they both have in common? A and B? Okay, so what I'm going to do here is I'm going to look at my 4 choices. Where they overlap, which ones have A and B in common? A. Isn't that the only one that has them in common? Isn't that the only, out of my 4 choices, isn't that the only one that has A and B in common? right? So like right there, I know I could stop, right? If that was my, I would be able to stop right there because out of all of them, the only ones that have A and B in common in the overlap is that one right there, right? So I really wouldn't need to do anything extra. I mean, I could, but porque, right? For the whites. Okay, so let's do the same thing here. Let's see, it's asking us to find the intersection of these two sets. So let's see if we can do that. So A intersection C. So remember what we're going to do here. We're going to look at this one here. There's A. Here's C. And we're going to say, okay, what letters do they both have in common? So A and C, and F, and is that it? And J? J, just J, right? Okay, so A, C, F, and J. And again, all we're doing is we're saying what letters, but are they both in A and C? It's just A and C, right? We're looking at those two. So we're saying, okay, what letters do they both do? Are they both in common, right? What letters are in common to both sets? So just be A, C, F, and J? Yeah, right? And that's what the intersection means, right? The intersection means when we overlap them, which ones do they have in common? Okay, so when I look at here like a number 19, I want you to notice what it's asking me to do. It's asking me to find A intersection C complement, right? So this is one thing I always recommend. If you remember like one of the very first videos that we did, it was like order of operations. And when we did order of operations, oh, you got to do parentheses and exponents, all that kind of stuff. I'm going to do the same thing here. Before I find the complement, I want to find what elements do they have in common. So just like we did in the problem before, what I'm going to do is I'm going to look at those two right there and I'll say, okay, which ones do they have in common? 1, 2, and 5? Okay, 1, 2, and 5. So now, when we're going to find A intersection C complement, what that means we're going to do, I'm sorry? Except those, right? So we're going to say, okay, what we're going to do is we're going to pick everybody that's in U that's not a 1, 2, or a 5. So I'm going to come back over here. Let's get rid of 1. Let's get rid of 2. Let's get rid of 5. What are we left with? 3, 4, 6, 7, and 8. Perfect. And you guys already know what you're doing. I could have stayed home. It's good. Very good. And it goes right there, right? All right. Okay, so let's take a look at this next one here. That says the chart below shows the most popular vacation destinations booked at a certain travel agency in 2003, 4, and 5. Okay, so they're asking us basically where would we put the location of Antigua, okay? So let's see. I'm going to come back over here. Here's 2003. Do I see Antigua at all in 2003? No, right? But we do see it in what year? 2004 and 2005. Okay, so what we're looking for then is we're going to say, where do 2004 and 5 intersect, but that does not include 2003? So here's 2005, right? And here's 2004. So we would pick this one right here, very good, which is 6, right? Because we want to include 4 and 5, but we don't want to include 3, so we wouldn't put that because that would be also including 3, right? Very good. All right, so let's go to the next one here. Number 21, it says a coffee shop collected the following information regarding purchases from 120 customers. All right, so if y'all remember when we did these here, this is typically what we would do. We would draw a Venn diagram, and we have 2 circles in this case. And one of them is going to be donuts, and the other one's going to be coffee. And so let's see if we can figure this thing out. So the first thing I'm going to do is I'm going to look for where they overlap, which is right there. It says 21 bought coffee and donuts. So that's going to be my number I'm going to put right there. Okay. And then when I come to this one here, it says 38 bought donuts. And all that tells me is that everybody that goes in this circle has to add up to the number, what, 38? And so if I grab my calculator real quick, let me just move it over here, turn it on. Okay, so if everybody in here has to add up to 38, and I already have 21, I'm going to take 38 minus 21. They're going to give me 17. So my number right here should be 17, right? And then, if I know that 64 bought coffee, that's telling me that everybody in this circle here has to add up to the number 64. So if I were to say, well, what's 64 minus 21? Isn't that 43? Right, that's going to go right there. Okay, and then, remember, we still have one more number to put down, and that's going to be the number we're going to put outside of the circles but still inside the box. So we had 120 folks. Let's take these numbers and add them together. So 17 plus 21 plus 43. That gives me a total of 81. So if I take that from 120, 20 minus 81, that leaves me with 39. So this 39 is going to be right there, right? And let's see, then we can go ahead and answer our questions. So the first one says, out of the people who surveyed, how many of them only bought coffee? Would you guys say 43? Yeah. And how many only bought donuts? Would you say 17? And how many didn't buy either? The 39, right? And so there you go, right? Good, excellent. All right, so let's see, let's keep moving along here. Okay, so this one here, number 22, almost the same as we did right now in 21, right? So first thing I'm going to do, draw a big picture like this. Okay, and let's see, what do we have? We have either a basement or we have a garage. Okay. Go like this, B for basement, G for garage, and then we'll go through each of our pieces. I'm just going to grab some water real quick. Okay, so let's see, 32 had both. So I know that this number right here is going to be a 32. And then it says 48 had a 3-car garage. So let's see, if I do 48, oops. If I do, what's 48 minus, what is it, 32, 16, that's going to be right there, right? And then 43 had the basement. So we say, what's 43 minus 32? Isn't that 11? Okay. And then we got to add those three numbers together. So 11 plus 32 plus 16. That gives me a total of 59. And how many houses did we look at? 79, right? So how many would be left over? 20, right? So that's going to be our number right over here. And then we can answer our 3 questions, right? So let's see. How many of them had a basement but not the garage? 11. And how many had the garage but not the basement? 16. And then how many had either? So remember with the either one. The either one is we're going to take everybody in that circle. So the either is kind of like the union. Put everybody together. So when we added them all up, wasn't that 59? Good, awesome. Very good. Okay, so this is the bigger problem because we're going to have a big Venn diagram here. We got the 3 circles here. Okay, so we got 1, we have 2, we have 3. Okay, so let's take a look what we have. We have the spa, we have the fitness center, and we have the children's club, right? Okay, so remember, we're gonna kind of work our way from the bottom up to the top. So the first one here says 5 had all three. So there's going to be our 5. And then the next part's going to say that 8 had a spa and a children's club. So yeah, this is a spa and this is a children's club. Then this region right here, this kind of football region, has to add up to 8. And if we already have 5 there, y'all agree that would be a 3? Yeah, good. Okay. And then it says 16 had a fitness center and a children's club. So here's my fitness center and here's my children's club. So those two circles overlap in this kind of football region. And if that number is going to add up to 16, if this is 5, wouldn't this one here have to be 11? Right? And then, let's see. It says 11 had a spa and a fitness center. So here's spa and here's fitness center. So then this kind of football shape has to add up to 11. If we already have 5, wouldn't that one there be 6? Good. Alrighty. So now, let's take a look at this first piece. 34 had a children's club. So that's telling me that everybody in the C circle, everybody in this circle here, has to add up to 34. So let's add up those numbers that we have already. So we have 3 plus 5 plus 11 gives me 19. So we say 34 minus 19 is 15. So that's going to be our 15 right there. And then let's go up one more. 24 of them had a spa. So that's telling me that everybody in the spa circle is going to add up to 24. So again, if I grab my calculator one more time, let's see, 3 plus 5 plus 6, 14. And yeah, so it's got to be 10, right? Because it was 24 total. So that one's going to be 10. And then fitness center was 56. So again, one more time, everybody in the F circle is going to add up to 56. So let's see, 6 and 5 is 11, and another 11 is what, 22? And 56, yeah, that's right, 34, right? Okay, so 34 right here. Okay, and then remember, we still got to find the number that goes on the outside, right? So remember, the way we find that one is just take all the numbers, yeah, and add them all up. So let me just clear this out. So 10 and 3 and 6, 5 and 15 and 11 and what, 34? Is that all of them? I think so, right? Okay. And that gives us 84. And we had a total of how many resorts? Right here at the top, 90? Right? So what's going to be our number on the outside then? If we have a total of 90 and we got 84, so wouldn't this be 6? Okay. All right. And now we can answer our A, B's, and C's. To me, this is the hardest part, and it's really more time-consuming, I think, than actually, like, really hard to do. Let's see. How many only had a spa? 10. And how many had exactly 1? So the exactly 1 is going to be the 10, the 34, and the 15. So 44, 10, that's 44. 44 plus 15 should be 59. And how many had at least 1? At least 1 was when we took everybody inside those circles and added them up. Wasn't that 84? When we added them all up together? And then, let's see, exactly 2. The exactly 2 are the numbers that we have in blue. So let's see, 3 and 6 is 9, and 11 more should give us 20. And then the last one, how many had none? Just 6. Perfect. You got it. Take it away. Good, very good. Awesome. Okay. Let's see. So let me ask you a question. Number 24, pretty similar to the one we just did, right? Y'all, I mean, we can go through it, but if y'all feel like you're okay on how to do them, we don't have to go through it, but I want to give you guys an opportunity. You want to go through it? No? You're all okay? Okay, then we'll go on to another one then. All right, I just want to make sure we have enough time to get to all the good questions, all right? Okay, so number 25 says, for the given sets, construct a Venn diagram and put them in the right form. So this is kind of like one of the problems we had done sort of earlier here. Okay, so remember what we're going to do. The first thing we're going to do, we're going to say, what letters do A and B have in common? So y'all agree D, H, D and H. Okay, so if I look, well, they both have D and H. Okay, so we're good with that part. Okay, so let's think about it this way. Once we pick D and H in part A, what are the other letters we're still going to have in part A? G and Q? Well, they both have the G and Q in part A, right? Okay, so that's not going to help me too much. Let's see. Once we pick the D and H that goes in B, what are the other letters that we still have in B? C and U? Well, they both have C and U, okay? So then what we're going to do is we're going to say, look, we've already used the letters C, D, H, G, Q, let's see, because they both had what, D and H, and A had G and Q, and we've already used U, right? So what's the one letter that we still have not used yet here? K. There it is. It's on the outside of those circles, right? Okay. All right. Okay, so let's take a look here at number 26. Directions are asking us to find A intersection B prime, or B complement, I'm sorry. So let's find B complement. So remember how we're going to find B complement. Here's the letter B. So what we're going to do is we're going to say, look, let's take the letter B and we're going to pick all the letters that are in this set that are not Q, S, Y, and Z. So I'm going to take away Q, we're going to take away S, we're going to take away Y and Z. So B complement will be whatever is left over, which in this case is R, T, U, V, W, and X. Okay? So now that we have that, we're going to find A intersection B complement. So I'm going to look at this set right here, and I'm going to look at this set right here. Those two that we put in the boxes. What letters do they both have? Do they have in common, I should say? Let's see. U. They both have the U. Oops. And W. And that's it, right? So it looks like our choice would be D. Alrighty. So let's see. Let's try number 27. Okay, so 27 says let's find A union B complement. Okay, so the first thing we're going to do, we're going to put them together. That's right, good. We're going to do it just like we would do in order of operations problems. We're going to do what's on the inside of those parentheses first. So remember what the union means. The union means take everything in these two sets and just throw them all together, right? So Q, S, U, W, what, Y and Z? Okay. All right. So that's how we find the union, right? We just put them all together. Now, if we're going to find the complement, what we're going to do is we're going to pick all the letters that are in here that are not those, right? So let's get rid of Q, and let's get rid of S, and let's get rid of U, and W, and Y, and Z. So then, aren't we left with R, T, V, and X? And that's which one, C? There you go, boom. Excellent. Very good. All right. So let's do the same thing for this next one, number 28. Let's find, first thing we're going to find is we're going to find A complement. Okay, so remember how we're going to find A complement. We're going to look at these letters right here. and we're going to pick letters that are in U that are not Q, S, U, W, and Y. So let's get rid of Q. Let's get rid of S. Let's get rid of U. Let's get rid of W. Get rid of Y. And you said it was what? R, T, V, X, and Z? Good. Excellent. Okay, so now, when we find the union, we're going to take those letters, and we're going to take these letters, and just put them together, right? Okay, good. So we're going to have a Q, and an R, and an S, and a T, a V. That was supposed to be a V. I don't know what looks like a V. An X, Y, and Z. No Y? Oh yeah, put the Y from the B, right? And then, oops, and then Z. There we go, Z. So let's see, which one does that look like? I guess D, right? D, Q, R, S, T, V, X, Y, and Z. There you go, perfect. Boom. You got it right there. Good, very good. Okay. All right. So again, we did a problem kind of similar to this one before. Let's see. We're trying to figure out which one does Marquette belong to. So let's see. In 1995, no, there's no Marquette. In 1998, there is. And there is also in 2000. So what region has 1998 and 2000 together? 1998 and 2000, wouldn't it be 6? Right? 6? Yeah. Yeah, good. There you go. Okay, and number 30 should be pretty much the same type of problem, right? We're looking for noodles now. So let's see, here's noodles. Noodles is a 95. And is it only 95? Okay, so which one has only 95? Just one, right? Region 1. There you go. Okay. Let's see. All right, we got another one, so on and so forth. This is, let's see. Where's Ruiz going to go? Okay, so the question here is asking us where we're going to put Ruiz. So here's Ruiz. Ruiz is voting yes on vote 1 and yes on vote 2, but they are a no on vote 3. So we want 1 and 2, but not 3. So that would be, what do you say, region 2? Yeah, good. Region 2. Boom, you got it right there. Excellent. Okay, so let's do 32. Let me go ahead and grab my pen again, and let me get the calculator going. Okay, so it says the graph here shows the land area of a country in millions of square miles for these years. Okay, it's asking us to find the percent increase. So I don't know if I mentioned this or not in the email, but I am going to provide you guys with a formula sheet, okay? So yeah, so you don't have to memorize a bunch of formulas. And you know what, if you give me one quick second, let me see. Yeah, no. I have a formula sheet. Here we go. I'm going to even show you what the formula sheet looks like. Yeah, I'll have a formula sheet when we take the final as well. Yeah, you don't have to. So formulas, I don't expect you to memorize them. I just want you to know how to use them, okay? So look, this is the formula sheet that you guys are going to have for the midterm, okay? So you remember when we did some of the, like the remediation part, like what was n, is equals, of is multiplied. So I have a little bit of that in there. But this problem here is asking me to find percent change. So here's my percent change formula. So again, you'll have a formula sheet. Those formulas will be there. You just got to remember how to use it, okay? So zoom in just a little bit so we can see that a little bit better. And here we go. Okay, so here's my formula. It says the amount in the latest period minus the amount in the previous period divided by the amount in the previous period times 100. Okay, so latest minus previous divided by previous. So if I come back over here, I'm just going to kind of write it sort of, okay, so let's write it right here. So we're going to go the latest period minus the previous period divided by the previous period times 100. Okay, so when I look at this particular problem here, and it's asking me to go, the first part's asking me to go from 1830 to 1850. Well, here's 1830, here's 1850. The latest period is going to be that one there. So what is it? 1.64 minus the previous, well, in 1830, it was 0.78 divided by that same number, 0.78, and then I'm going to multiply it by 100. So the one thing I want to mention is when you're doing this on your calculator, here we go. When you're doing this on your calculator and you go 1.64 minus 0.78, make sure you hit equals. And then do your divide by 0.78. And then from there, you're just going to multiply it by 100 so that we can write it as a percent. And I'm coming up with 110.25, 26. Who does it ask me to round to? It asks you to one decimal place. Okay, so if we're going to go one decimal place, would you write 110.2 or 0.3? 0.3, right? So 110.3. And then we're going to do this problem all over again, right? And we won't do all of them right now because I think once we do a couple, we'll get the hang of it. But now look, we're going to go from 1850 to 1870. So 1850 to 1870. This is going to be my latest. And this one here will be my previous, right? Okay, so we're going to take 1.72 minus 1.64 divided by 1.64 times 100. And again, I'll do that here. Try that out. 1.72 minus 1.64 equals, and then divide it by 0.64. Okay, and then multiply it by 100. Okay, so again, I'm going to go to one decimal place. Question, 4.8 or 4.9? 4.9, right? And then you would, basically you're going to do that process 2 more times, right? So the one thing I want to mention, for those of you who are here, is, so, how many of you already have a scientific calculator? So you have a calculator, you have a calculator. Do you have one too? Okay, so I'll give you a heads up. Do you have, you don't have one at home or anything like this either? Okay. So then my recommendation, and I'll actually pull it up here, so for those people who are going to watch the video, they'll be able to see it too. And I think I might have mentioned this once earlier in one of the videos. Scientific calculator, shopping. Yeah, I did in one of them, right? Okay, so guys, what I would recommend, here we go. This is one that I would recommend right here, and I have one similar to that right here. And it's like 13 bucks, and I think somebody said you have the same one right there, right? Very similar to it. Did you already have that one, or you just recently buy it? Okay, you already had it. So 12 bucks. There's another one. It's a Casio. Where is it? Where is it? Where is it? Okay, not that one. Not the 250. Here we go. So like this is 15 bucks. I think somebody in my, because I have this class also on Monday and Wednesday here at school, and somebody says that I think they paid 12 or 13. So, and I have one of those two here too. So, if any of y'all, before you leave, if y'all want to take a look at them, I have some up here, okay, that you can kind of take a look at. But you definitely want to pick one up, especially for when we do the other problems in the review, okay? Let's see. So, let's go ahead and, instead of finishing off, because the process is going to be the same, let's go ahead and go to the number 33. So it says, let's see, a person earns $18,200 in 1 year and gets a 5% raise. What's the new raise? So remember, we're going to take 18,200. 5% as a decimal is 0.05. And again, I'm just going to multiply my numbers here. So 18,200 times 0.05. Okay, so I'm coming up with 910 as the raise, right? But the question is asking me to find the new salary. So you're not just going to get 910, right? You're going to have to add that back into the 18,200. And so now you're going to have 19,110. Okay, let's see. 34 says the cost of a fish dinner to the owner of the Golden Wharf restaurant is $10.75. They sell it for $19.75 to determine the percent markup. So I told y'all I'm going to have that formula sheet. If you look right here, here we go. Here's my formula sheet. Here's my markup formula. Okay, so again, you'll have all this information on whenever you come take the midterm. So look, it's the selling price minus the dealer's cost divided by the dealer's cost times 100. So let's go like this. Okay, selling price minus the dealer's cost divided by the dealer's cost times 100. So let's see, they're selling it for $19.75. It costs them $10.75 divided by $10.75 times 100. So let's see, 1975 minus 1075 equals divided by 1075 times 100. Okay, and again, let's see, it's asking me to round to one decimal place, so let's do that. So what do you say, 83.7 or 0.8? 0.7, right? So 83.7% is our markup. There you go. Awesome, very good. All right, so we're knocking a few of these problems down. Let's go ahead and try number 35. We're almost done. We got, I think there's 15 or 25 problems on this review, so we got another 15 or so to go. Let's see, determine the simple interest. So let's see, simple interest. Oh, again, just a quick reminder. Here we go. Isn't it? Here, there you go. Simple interest formula, guys, compound interest formula, present value formula. You'll have all of them, okay? And then you'll even have this table, and I gave you this stuff as well. So you'll have that kind of stuff there, okay? All right, so simple interest. Let's see, I equals PRT. So I equals PRT. Principal is 440 times my interest rate. Remember, we got to move our decimal 2 spaces to the left. 0.225 times 4.75 years. And again, we're just going to multiply here. So 440 times 0.0225 times 4.75. There we go. And okay, so this problem here, I want to say it's asking us to round to the nearest cent. So guys, remember, cent's going to be 2 decimal places. So would I put 47.02 or 0.03? 03, right? Good. 47.03. And I want to say that in that handout that I gave you, if you look towards the end, the last 2 pages or 3 pages are going to be the answers, okay? So if we were to double check, let's see, what number was that, 35? Let's go like this. Hey, look, $47.03. You got it right. Okay, nice. Okay, let's see, where are we? Here we go. Okay, so let me skip number 36. Well, you know what? Let's do 36 because it's a little bit different. It has the days. So I'm still going to use the same formula. I equals PRT. So our principal is 700. Our interest rate is 0.065. In this case, it gives me 60 days. So remember, I'm going to write it as 60 over 360, right? And then again, I'm just going to grab my calculator and do it to it. So 700 times 0.065 times 60 divided by 360, and then hit equals. And again, if I go to 2 pennies, I should be coming up with $7.58. So 7.58, and there's my interest, right? All right, let's do 37, and then we'll we'll move on to another one. I do want to do 37 just because we do have that fraction there. So again, I equals PRT. So 1450. So first off, 4.5%, everybody agree that's the same thing as 4.5%? And then if I move it 2 spaces to the left, 0.045. And then, let's see, it did give us 9 months. So y'all agree we're going to go 9 over how much? Over 12, right? Because there's 12 months in a year. Excellent. Good. So 1450 times 0.045 times 9. Let's divide that by 12. And again, if I go to 2 decimal places, I should be coming up with $48.94. $48.94, right? Okay. All right, so let's take a look at problems like 38 and 39. They're similar problems, and they're just telling me to use the simple interest formula to find the missing value, right? So if you notice here, we already know what the interest is. It's $95.85. We know the principal is $17.75. We do not know the value of R, so I'm going to leave that R right there. And we know that T is 3 years. So if I grab my calculator and I say, what is 1775 times 3? That's giving me 5325. So I'm going to have a 5325 with the letter R. And then we're going to go ahead and divide. So if I grab my calculator again and say, what's $95.85 divided by my answer, which is right there, the 5325. I'm coming up with 0.18 or 0.018. R equals 0.018. And it's asking me to write it as a percent. Wouldn't that just be 1.8%? Okay. And guys, I would do 39 exactly the same way, right? I would do that one exactly the same way. It's the same sort of problem there. So let's try number 40. And again, 41 is going to be pretty much the same way. So I was actually doing these problems like 40 and 41 in my class on Monday night. And I was telling them that like a problem like this is really just a calculator type problem. So if you notice here, let's see, the P is 4,000. The interest rate is 0.08 because it's 8%. The N is the number of times it gets compounded. So semi-annually would be twice a year. And then the T is going to be 3 years. And it's just plugging it in, right? So I was telling them, like, look, because somebody was saying, like, how much work do I need to show? And I said, this is really all I really would like to see. You remember what we're going to do with those two numbers? Multiply them. So 2 times 3 is going to give me, I said, that's all the work you need to show me. Just write the numbers down where they belong. And then, like you said, it's really just a plug, calculator type problem, right? So we're going to type it exactly as I see it, 4,000 times, parentheses, 1 plus 0.08 divided by 2, close it off, raise it to the power of 6. It equals, and I'm coming up with 5,061 and what, 28 cents? So 5061.28. 5061.28. And that's really all there is to it, right? So, you know what, before So for those of you who are here, okay, so I'm going to type in exactly what I had like on that problem. It was 4,000, and then times, and then we had parentheses, 1 plus, it was 0.08, 0.08 divided by 2, and then we closed them off. And so if you have a calculator like this one here, there's my exponent button, and we said 6. And if you have a calculator like this one, that little button right there is my exponent, and we had 6. And then we hit equals, and if you notice, we come up with the same exact thing, right? So this is for those of you who are here, depending on which one of these calculators you get, guys, same exact thing, right? So you can see exactly how I'm plugging it in. Now, so the reason why I like these calculators here compared to, let me see, there was one that, there we go. There was one that had come up earlier, and it was kind of cheap. This one here. What I don't like about this one doesn't have the display like these. Yeah, see how you can see everything that I'm writing up here? The other one here doesn't have, I'm sorry, where is it? Here we go. This one here doesn't have that little display. You won't be able to see everything, okay? So that's why I say, you know, instead of like $8, you know, spend another 2 or 3, you have the display, it's a little bit easier to see, make sure you're on the right track, okay? All right, so look, for number 41, let me just set it up. I won't actually do the calculator part because I don't think we need to. But in this case, we know that the P is 4,500. The interest rate is 0.03. The N is 4 because it's being compounded quarterly. And the T is what, 3 years? And so then again, all I'm going to do and then these get multiplied together to the power of 12, right? And you plug them in and you're done. Okay, so let's keep moving along here. All right, same kind of thing here, compounded monthly. Let me at least just set them up, because again, I think the calculation part is easy. It's just how do I set it up? R is 6.5%, so it'd be 0.065. And if it's being compounded monthly, anyone know what N is? How many months in a year? 12, there you go, good. And then our time here is 4 years. So then again, I would just write it out, 9,500, 1 plus 0.065, excuse me, over 12. We're going to multiply those two numbers, and my power will be 48. All right, so let's go ahead and do 43 because this is a slightly different problem. It's asking me to use the present value formula. So again, if I just to give you a heads up, you will have the present value formula. Again, all these formulas will be given to you. So if you notice, it's kind of similar to the other one, but I'll go ahead and write it out. So let's see. Write it over here to the side. So P equals A, 1 plus R over N to the power NT. Okay, so we want to have 80,000. Let's see, 1 plus, my interest rate is 6.2%, so it'd be 0.062. And I want to say that this problem says it's being compounded monthly. So if it's being compounded monthly, my N is going to be 12. And then my power is going to be 12 times 14. So I'll just do that right here because it's easy. 12 times 14 is 168. And again, just so you can see how I'm going to do this, it's going to be, again, straight plug and chug, right? So I see 80,000 divided by parentheses 1 plus 0.062 divided by 12 raised to the power of 168. It equals, and I'm coming up with 33,658 and 35 cents. So 33,658 and 35, 33,658 and 30, what did I say, 38 cents? I forgot what I had. 35 cents. Again, very much plug and chug, right? So the one thing I want to mention is, well, like when I'm looking at these problems, it says use the present value formula, right? So it's they're kind of being specific. Sometimes there are, sometimes they're not. But the word you're looking for a lot of times, how do I know when I'm going to use the present value formula? When I see the word now. They don't, it's not necessarily telling you. Okay, so that's, so good question. I was actually doing this, I was doing this last night in my night class. And what I was telling them was, think of what the word present means. Like, if we're thinking about, like, yesterday was the past, right? Today is the present, tomorrow is the future. So present is going to be the now. So when you're doing your problems, if it's it'll be specific. It'll say, how much do I have to have now? That's telling me, okay, you know what? Let's use the present value formula. Okay, the other ones will say how much are you going to have when you withdraw the money or that kind of thing, and that'll tell you you're going to use the compound interest formula. That's right. That's right. So then you know what? Let's go ahead and let's do something like some of these here, because again, I want to make sure, like problems like 44 and 45, they're very similar to 43. Okay, but let's do something like this one here, again, just to make sure that we're okay with this sort of idea. And I know these are the two sections that y'all were doing this week, so I don't know how many of you already had a chance to get to it, but if you haven't, it's pretty simple. The first thing we're going to do is whatever the amount of money we're going to finance, step number one is always going to be, let's take that number, in this case it's 65,000, and we are always going to divide it by 1,000, and the reason why we're always going to divide it by 1,000 is because that table is for every $1,000 worth of mortgage, okay? So first thing is when I do that, the number we're going to end up getting is 65, okay? So in this case, 65 is going to be the number that I'm going to multiply. And what we're going to do is we're going to say, look, we're going to go to 6%. So here's 6%. So I'm going to look at everybody right here. And then we're going to look at 15 years, which is this one right here. So that's going to be the number that I'm going to multiply it by. 8.43857. And all I'm going to do is just multiply it out. So let me clear this. 65 times 8.43857. Okay. And again, because we're dealing with money, we're obviously going to go to 2 decimal points. So I'm going to say $548.51. 548.51, right? And there's my monthly mortgage payment, right? So just to let you know, the calculation is actually pretty simple. It's take this number that we have right here, take your mortgage, and divide it always by 1,000, okay? So look, let's do another one similar to that. Let's see. I'm going to kind of skip over 47 because it's exactly the same. Let's do this one here because this one does require me to do a little bit of work. So I want to do this one in 48 because it does ask me to do a little bit of work. So look, the house selling for $245. Okay, so it says she has to make a 20% down payment, and then she's going to have a 30-year mortgage with a rate of 5%. So I know I said the first thing I'm going to do is take my number and divide it by 1,000, but that's the amount that I'm going to divide by 1,000 is the amount that we're actually going to borrow. So in this case, part A is asking us to find what's her down payment. Okay. So her down payment is going to be the 245,000 times, times the 20%, so times 0.20. So we're going to say 225 times 0.20. So she has to come up with $45,000 as her down payment. So right here, her required down payment is gonna be $45,000. Okay. Now, part B says, let's find the mortgage. Well, the way we're gonna find the mortgage is we're gonna take the $245,000 and we're gonna subtract off her down payment. So wouldn't we just get $200,000? And that's gonna be her mortgage. Okay, so now so look, that's the only thing extra we've done so far. Now when we do part C, because this is amount that she's borrowing, that's the number that we're going to divide by 1,000. So look, we're going to get rid of those. That's going to be my number that I'm going to multiply. So we're going to go like this, 200 times. Remember how many years we're looking at? 30 years and what percent? 5%? Okay, so look, here's 5%. And here's 30 years. So I'm going to multiply it by 5.36822. Okay. So let me grab my calculator. Let's go 200 times 5.36822. And here's our monthly mortgage payment. And 64 cents. So 1073 and 64 cents. Boom. So again, to actually do that part, to me, this piece right here, what I was telling my class last night, guys, is that this piece right here is actually pretty simple to do. It's just how do I get to that step, right? And I said, I think the hardest part is reading through everything and making sure that I understand what are they telling me, okay? So when they tell me, look, we're gonna have to find their down payment, they should be giving me a percentage for my down payment, right? So I'm gonna find that amount, and we did, which was right here. And then notice how we found the mortgage. We took the price of the house and we subtracted the down payment, and that just tells me how much I'm borrowing, right? So the mortgage is really the same thing as what's a loan, right? You're buying a car, you put so much money down, the rest of it is how much you're gonna be paying off on, right? And look, percent markdown, we did a problem similar to that. And here's another one again. This is very similar to the one we just did, okay? So, anyway, let me ask you a question. How did y'all feel? Like, does this make sense? Y'all feel okay about it? Okay, so, quick question. Let me stop this part here.